Okay, now we're on page 5. Let's get going on this page. Question number 47 tell whether the function represents exponential growth or decay problem. Okay, so what you need to do is when you're dealing with exponential functions, they're often the form of y, keep this going, y equals a times b to the x power, where a is the starting point, b is your multiplier, and this is your exponent. And really what you need to do is just look at the b. Just look at the b. If the b is greater than 1, then it is going to be a growth. But if the b is between 0 and 1, then it is decay. So let's look at this. What is our b? Our b is 2.5. It is greater than 1, so this is growth. Check out this one. What's our b? Our b is 1.3. That's between 0 and 1. Therefore, this one is decay. Look at this one. Here we got 2. In this situation, because it's 2. Oh, look at that. Try to sneak this little negative thing. I'm going to get rid of that. Ignore that. Because it's 2, it's we're talking bigger than 1, so this is growth. And because it's 0.5, we're talking between 0 and 1, and therefore it's decay. Okay, now what they try to do is they threw in these little negative things, which would mean when you throw in the negative, this negative comes in there, it makes that 1/2, this makes that a 2, so really this changes it to a decay, to a growth, and a growth to a decay. But I really didn't teach that to you, and I don't believe that's going to be on the test, so this is good as it is, right there. Okay, moving on to number 48. 48 says, find the amount of a $1,000 investment earned 5% compounded annually for 6 years. For this, we're going to use that compound interest formula that I taught you. Remember, we have A is equal to our principal times 1 plus our rate of change over n times t times n to the power t times n. So we got to figure out the p, the r, the n, and the t. Okay, so our p is our initial principal, so p is equal to 1,000. That's right, given right here. Our r is our rate of change. It's 5%. R is equal to 5%. Change that to a decimal, so that's 0.05. Compounded annually. Well, because it's compounded annually, that's once per year, so our n is equal to 1. And for 6 years, so our t is equal to 6. So we just take all those things and plug it into our formula. So let's do that. So we have 1,000 times 1 plus 0.05 over 1 to the 6 times 1. If you take that and plug it into your calculator, let's do that. Get this out of focus so you can see that. So we have 1,000 times 1 plus 0.05 divided by 1, which was kind of unnecessary. That's raised to the 6 times 1, which is just 6. And so after 6 years, our investment will have $1,340. This is equal to $1,340. Okay, so that's for number 48. Okay, moving on to number 49. 49 says, find the amount of a $1,400 investment earning 5.25% interest compounded monthly for 4 years. Okay, so same situation here. We need to find our P, this 1,400. We need to find our R, well it's 5.25, so we got 5.25%, but we got to move that decimal over, so this is really 0.0525. We need to find our N. Well, it's compounded monthly. How many months are there in a year? 12, so n is 12. And the duration, or t, is equal to 4. So let's put that all together in our formula. We've got 1,400 times 1 plus 0.0525 all over 12 to the 4 times 12. Okay, so let's get that into our calculator. So we got 1,400 times 1 plus 0.0525 divided by 12 all over to the, now remember up here, put this in parentheses, 4 times 12, like that. Push enter, and we get $1,726.35. So this equals $1,726 and 30. Actually, if you round up, it would be 36 cents. There we go. Okay, that's number 49. Now number 50, 51, 52, 53, and 54, those are all using logarithms. We're going to skip those. Those were in standards, so those won't be tested. Skipping those. And now we're moving back to Chapter 5. Chapter 5 is solving quadratic functions and factoring and all that stuff. So let's start on problem number 55. This really says solve for the x here. So we want to solve for that. Oh, let's get this changed up. Make sure it's focused for you guys. Okay, so it says solve for x. Well, here what we want to do when we're solving for this x is we want to make sure that we get whatever is squared by itself on one side. And then what we're going to do is we're going to take the square root of it. Okay, so we want to get this by itself, this x squared. So the first thing I'm going to do, let's just do a railroad track. Let's add 14. Add 14. So we get 3x squared minus 2 is equal to 127 plus 14. That's 131. That's 141. Okay, now let's divide everything by 3. Divide by 3. So we have x squared minus 2 is equal to, that's 141 divided by 3. 47. Next up, let's add this 2, add the 2. So we have x squared is equal to 49. So you got to ask yourself, what times what? What times itself is 49? Well, the one obvious answer is 7, but there's another one. Negative 7 times negative 7 is also 49. So your two solutions are 7 and negative 7. At this point, though, if you weren't sure about it, you take the square root of both sides. And so you get x is equal to, now when you take the square root, this is where you have to do the plus or minus. So what's the square root of 49? 7. So x is equal to plus or minus 7. That's for number 55. Okay. Number 56 says factor this. Well, we want to see what's in common in both things. Are there any factors in common? Well, 12 and 3 have negative 12x. Well, sorry. Look first at the terms. Let's look at this term and this term. Are there any factors in common in those terms? Well, 12 is divisible by 3, and 3 is also divisible by 3. So we could factor out a 3. In fact, we could factor out a negative 3 from 1 and 2. Let's take out a negative 3. Now, if we do that, what's negative 12 divided by negative 3? Well, that's 4. And negative 3x divided by negative 3, well, that's just x. So once you factor this, what you get is negative 3 times 4 plus x. Moving up to number 57. Here it says factor these. So again, let's look at the two terms, see if there's anything we can take out of these two terms. Well, both of them have an x. So let's take on an x. Do they have more than one x? Well, the most they have, this one has two x's, this one has one. Remember, if you take something out of this one, you got to take it out of that one. And since this one has one and no more than that, you can only take out one x. Let's take a look at the coefficients in front. We've got negative 5 and negative 10. So what can we take out of there? Well, we could take out a negative 5. And if we do that, we take a negative 5, factor out here, and an x. Well, all we have left there is our x. And if we take a 5 out of this, then we just have a plus 2. And there's factor. Moving on to number 58. What's in common between these two things? Well, first let's look at our coefficients. We've got 6 and 18. Can we pull a 6 out of that 18 or something like that? Yeah, we can. So let's pull a 6 out. So 6 on the outside. Now what else can we pull out of here? Well, it looks like the biggest degree x is x squared, so we'll pull an x squared out. Or sorry, the least degree x is x squared. So what do we have left here? If we pull a 6 out, we got 6 divided by 6 is just enough. That's 1. X to the third divided by x squared is just x. And now 18 divided by 6 is 3. So this factored is 6x squared minus 3. Moving on to number 59. Okay, so here we got x squared minus 25. There's really nothing in common between these two things. So we got to think of what other ways could we factor it. Well, what we can use is, there's a formula that we can use. It's x minus a, x plus a. But I'm going to teach you the other way of doing it. Remember, we can use this, change this into a trinomial of x squared plus 0x minus 25. Okay? And we make our little x thing. And the b we put right here, that's 0. That's going to be our addition. and the negative 25 and put right there. That's going to be a multiplication. So you got to ask yourself what times what is negative 25. The add together by 0. Well, if you do in your head, we got 1 and 25 that do it. What we can also do, 5 and 5. 5 and negative 5. If we add these two together, we get 0. If we multiply them, we get negative 25. So this factor would be x plus 5, that's from there, and x minus 5, that's from there. Okay, moving on to this one, same idea. We'll make our nice little x. It's going to be our addition. This is going to be a multiplication. Put the 5 on top, the 4 on the bottom. So what times what is 4? The add together would be 5. Well, let's start with 1 and 4. Would that do it? Yeah, it would. 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. So, again, let's just take this. We've got x plus 1. And we got that. We got x plus 4. And there's your solution. Moving on to this one. Well, okay, we got a number in front there, right at the beginning. So when you see that, when you got that number in front, what you want to ask yourself is, could you factor something out of each of these terms? Is there a greatest common factor? And in this situation, we got a 3, 3, and 18. Well, there is. And 3 is the greatest common factor of these coefficients, so let's factor that out. So if we do that, we have 3. This is x squared now. This is x, and this is 6. Okay? So let's just factor this now. Take that 1, put it there. Take the negative 6, put it here. Remember, this is plus. This is plus, and this is multiplication. What times what is negative 6 that add together would be 1? Well, 1 is 6. No, that doesn't do it. We've got 2 and 3. Oh, there we go. 2 and 3. So which one's positive? Which one's negative? Well, since this is a positive, this one has to be positive when you add these two together, so that's got to be the negative. So if we were to factor this, we got the x minus 2. That's from here. And we have the x plus 3. That's from here. Don't forget about this 3 at the beginning. We'll take that, put it right there, and there's your solution. Moving on to number 62. I got x squared plus 3x minus 18. Looks like there's nothing you could factor out of each of these, so I'll just go straight to this. Multiplication, addition, we'll put the 3 on top, and negative 18 on the bottom. What times what is negative 18? They added by 3. Well, we'll start with 1 and 18. We know that multiplies by that, but that doesn't give you 3 when you add them together. Let's do 2 and 9. 2 times 9 is 18. That doesn't add together, it'd be 3. How about next one, 3 and 6. That makes you 18 when you multiply it. Oh, and when you add it together, it becomes 3. So let's do 3 and 6. But one's got to be a negative, right? And since this is a positive, this one's your negative. So your solution to this, we got x minus 3 from that one, and x plus 6 from that one. Moving on to this one right here. Again, I'm going to factor this, negative 18, or negative 8 there on top, 16 on the bottom. What times what is 16? The add together would be 8. Okay, so we'll start with 1 and 16. That doesn't do it. That doesn't add together. It'd be 8. 2 and 8. That doesn't do 8 either. 3, nothing in 3, so that doesn't make sense. 4 and 4. There you go. 4 times 4 is 16. Okay, so what are these? If they're both negative, then they would be added together to be negative 8. And if they're both negative, then the multiply would be a positive. So there you go. So what we have is x minus 4, x minus 4. And since these are the same thing, you can change this as x minus 4 squared. Okay, we've got one more problem down here. This one's a little bit more complex. Notice we got the 3 in front. Just like in problem 61. On 64, we can't factor that 3 out of each of these. So we have to call the slide swing method. The first step in the slide swing method is to take this 3 and multiply it by the 4. So let's do that. 3 times 4 is 12, so we will rewrite this as x squared. That's from that, plus 11x, and then minus 12, because we multiplied these. Okay. Now we treat it as before. We make our x. And we put the 11 here, and negative 12 there. So what times what is 12? To add together would be 11. Well, 1 and 12. In this situation, the 1 is negative, so we'll just go like this. X minus 1, x plus 12. Okay, now this sadly, we can't stop at this point. Because we took this 3 and swing it out to 4, what we do is take this 3 again. And we have to divide the 1 by 3 and the 12 by 3, okay? Now, the next step is simplify this down. Can you simplify this at all? 1 divided by 3? Nope, so we'll just write this as x minus 1 over 3. And can you simplify this down? Oh yeah, you can. X plus 12 divided by 3 is 4. Now the last step is called the swing. What you do is you take any denominator left over and you swing in front of the x. So what we get is x, or 3x minus 1, x plus 4. And that's the factored answer. Okay, moving on to, could you see any of that stuff that I was doing? I hope so. Here it is. I'm sorry, I didn't know it wasn't lined up. Here you go. Take a look at that. Okay, moving on to number 65. Graph the function f of x is equal to x squared minus 2x plus 3 and find the vertex. Is it a maximum or a minimum? Well, you don't really have to graph it to determine if it's a maximum or minimum. The only thing you really need to do is look at the x squared term. Okay, let's look at it. If this x squared term is positive, we know that its a parabola is upward, like that. And if the parabola is upward like this, we know the vertex, which is right here, this is the vertex, is a minimum. So in this situation, because it's positive, the vertex is a minimum. Now if this x squared had a negative in front of it, it would be like this, and thus making the vertex a maximum. But in this situation, the vertex is a minimum, because the x squared is positive. Okay, moving on to number 66. Solve the equation by factoring and apply the zero product property. Okay, so what we want to figure out is what do we have to put into this for x's to make this 0. So the first step to do this is just like when we're factoring above. We want to factor this. Okay? So we'll get our factor tree. We've got negative 5 and 6. What times what is negative 5? They add together to be 6. 1 and 6 does it. But this is positive from 1 times that won't. Okay, so that doesn't do it because 1 and 6, even though you would think it would add together to be negative 5, these both have to be either positive to make that positive or negative, and that won't get us to a negative 5 when you add them. So 2 and 3, see, there we go. So we got 2 and 3. Both of these are negative. Okay? So what we have is this right here is x minus 2, x plus 3 equals 0. So now what you need to do is you need to ask yourself, what do you have to put in for this x to make this 0? Because if this whole parenthesis is 0, 0 times this is 0, which makes the whole thing equal to 0. Okay, so what minus 2 is 0? Well, 2 minus 2 is 0. So one solution is x is equal to 2. If you put 2 in for here, 2 minus 2 is 0. 0 times this is 0. Okay, how do we make this one 0? X plus 3. Well, what plus 3 is 0? Well, negative 3 plus 3 is 0. So negative 3 is your other solution to this scenario. And that is the end of page 5.